Hello, students! I am absolutely thrilled you are joining us today for this explainer. Look, we are going to completely conquer chemistry numericals today. If you have ever looked at an exam question asking for moles or molecules and felt a little bit of panic, just take a deep breath. Today, we are going to make it joyful, simple, and super easy to understand. We are going to build this up step by step. So, here is our roadmap for today. We've got 1. Cracking the molar mass. 2. Moles, the magic formula. 3. Counting the molecules. 4. Tricky units, kilograms. And finally, 5. The master challenge, milligrams. All right, let's kick things off with section 1, cracking the molar mass, the basic building block. Now, you're gonna wanna treat these atomic masses like your absolute best friends. Hydrogen is 1, carbon's 12, nitrogen is 14, and oxygen is 16. You will usually spot these numbers neatly printed in the general instructions of your exam paper, or sometimes just right next to the question. But honestly, my best advice is to just memorize them. Having these at your fingertips is gonna save you so much time. Let's see how simple addition builds our molar mass. Take nitric acid, formula HNO3. First, we have 1 hydrogen atom, so that's a 1. Next, 1 nitrogen atom, which is 14. Then we have 3 oxygen atoms, right? So we multiply 3 by 16 to get 48. Finally, just add the whole thing up. 1 plus 14 is 15, and 15 plus 48 gives us exactly 63. And please remember, the unit for molar mass is always grams per mole. Moving right along to section 2, moles, the magic formula. Unlock the numericals. Okay, here it is, your magic key for exams. The formula to find the number of moles, which we indicate with a tiny n, is incredibly straightforward. It's literally just the given mass, capital W, divided by the molar mass, capital M. That's it. Finding W and M from the question is the real secret here. Once you nail those two things down, you have completely unlocked the problem. Let's put this magic into action with a classic 2-mark exam numerical. Say you're asked to find the moles in 22 grams of carbon dioxide. Your given mass, W, is neatly provided right there, 22 grams. Next, we calculate our molar mass, M, for CO2. Carbon is 12, plus 2 oxygens, which is 32, giving us a total of 44 grams per mole. Pop it into the magic formula, N equals 22 divided by 44. Both are in the 11 times table, right? So that simplifies to 1 by 2. And 1 divided by 2 gives our final answer of 0.5 mole. Beautiful and simple. Awesome job! Now let's step up to section 3, counting the molecules, finding the invisible. Behold Avogadro's number, 6.022 multiplied by 10 to the power of 23. To put that into perspective, if you had a mole of marbles, they would literally cover the entire Earth miles deep. It's massive. And again, this vital constant is usually given right there in the general instructions of your exam paper. So how do we count these invisible molecules? We just take that number of moles we found, little n, and multiply it by that giant Avogadro's number. It's a direct stepping stone link right from our previous answer. Sticking with our carbon dioxide example, let's see how this plays out. We take our previously calculated moles, n equals 0.5, and bring in Avogadro's number to multiply. Now watch the math here, it's pretty neat. You can write 0.5 as 5 into 10 to the power of minus 1. Multiply 5 by 6.022, and you get 30.110. Combine the powers of 10, so 23 minus 1 is 22. But to write it perfectly in scientific notation, we shift that decimal 1 digit to the left, which bumps our power back up to 23. Bam! A beautiful final answer of 3.0110 into 10 to the power of 23 molecules. Let's try one more example to really lock it in. 12 grams of acetic acid. Our given mass is 12, and the molar mass is 60. Dividing 12 by 60 gives us 1 over 5, or 0.2 moles. Now, to find the number of molecules, just multiply that 0.2 by Avogadro's number. Multiply the base numbers, shift those decimals exactly like we did before, and we land smoothly on 1.2044 into 10 to the power of 23 molecules. See, you guys are absolutely crushing this. All right, let's look at section 4. Tricky units, kilograms, matching is key. Let's see what happens when examiners try to trick us. Listen closely because this is where a lot of students lose marks, but you won't. Our magic formula, N equals W upon M, has a very strict rule. The unit of molar mass is always grams per mole. But what if the examiner sneakily gives you the given mass, W, in kilograms? You have to remember that 1,000 grams equals 1 kilogram.
Your units for W and M absolutely must match before you divide.
Check out this trick question. Calculate moles in 44 into 10 to the power of minus 3 kilograms of CO2. W is in kilograms. But we know the standard molar mass of Ca2 is 44 grams, so we just convert M to kilograms to match. 44 grams simply becomes 44 into 10 to the power of minus 3 kilograms, and look at how easy the math becomes. N equals W upon M. It's the exact same number on the top and bottom. They cancel out perfectly, leaving us with precisely 1 mole. Multiply 1 by Avogadro's number, and your final answer is literally just Avogadro's number. So easy when you match those units.
Okay, deep breath. It is time for Section 5, the Master Challenge, milligrams, the ultimate test. But don't worry, you already have every single tool you need in your brain right now. Let's visually contrast this. 1 gram is equal to 1,000 milligrams. Remember our golden rule, always convert your standard molar mass from grams to match the given unit. Honestly, this brilliantly illustrates why unit matching is the absolute secret to getting perfect scores on these numericals. Let's walk through this one patiently. Calculate the molecules in 0.032 milligrams of methane. First step, let's make W easier to read by shifting the decimal 3 places. Now it's 32 into 10 to the power of minus 3 milligrams. Methane, CH4, has a standard molar mass of 16 grams. Let's convert that to match by multiplying by 1,000. So M becomes 16 into 10 to the power of 3 milligrams. Now divide W by M. 16 goes into 32 2 times, but keep a sharp eye on the powers of 10. The 10 to the power 3 in the denominator moves to the numerator and becomes 10 to the power minus 3. Minus 3 plus minus 3 gives us 10 to the power of minus 6. So N is 2 into 10 to the power of minus 6 moles.
What a brilliant calculation. Finally, we take those 2 into 10 to the power of minus 6 moles and multiply it by Avogadro's number. 2 multiplied by 6.022 is 12.044. Now for the powers. 23 minus 6 leaves us with 17. Tweak that decimal point and we land at our grand final answer, 1.2044 into 10 to the power of 18 molecules of methane. Notice how that power dropped all the way down from 23 to 18? That's simply because we started with such a tiny, tiny speck of mass in milliliters.
You know what? You have done absolutely incredibly today. Step by step, you mastered atomic mass, cracked the magic formula for moles, multiplied your way to molecules, and completely destroyed the tricky traps of kilograms and milligrams. I am super proud of your focus. Now that you hold the magic formula, look around your house. Which household compound are you going to calculate next? A glass of water? A pinch of salt in your kitchen? Keep practicing these stepwise skills, and I will catch you in the next explainer. Thank you and happy learning.